Welcome to another lesson of transparent physics. This one is a companion video to basic equation manipulation skills. This one is going to discuss common equation manipulation mistakes. And mistakes are okay. It's expected that you're going to be making mistakes when you're learning a new skill. The idea is to make them all as soon as you can so that when it comes time for the exam, when there's an opportunity to make a mistake, you've already done it, you've learned from it, and you can avoid it. So what I have done is I've compiled some common equation manipulation mistakes, algebraic manipulation mistakes that I have seen in my years in the classroom. This is by no means an exhaustive list of examples. It is just some common ones that I see. So let's take a look. We're just going to go through. I'm going to show you the incorrect approach each time. We'll talk about why it's wrong, and then we will show you the correct one as well. And in teacher stereotype, I'm going to use the red one for the mistake, and we'll just use black for the correct value each time. So let's take a look here. Okay. I think we can afford to zoom in a little bit here. Number one. So we've got this value, or this equation, A equals B minus C. And the problem's asking us to solve for B. Do I want to solve for B? Okay, well, I guess as appropriate as it is for a lesson on mistakes, I don't want to start by solving for B. We're going to solve for C instead. So I'm just going to get my first correction in right out of the way there. All right, let's solve for C instead of B. I think that's going to give us a better example of what I'm trying to show here. So we are looking to get C by itself, so we want to get rid of B. So according to what we talked about in the previous video, I'm going to take this B and I want to get rid of it. So effectively, when we're looking at this, we can think of it as A equals B plus a negative C. So when we solve this out, we can subtract B from both sides, and we have A minus B equals C. All right, so we got B away from this side, drop C down, and there we go. And the mistake, if you guys saw it, I sort of telegraphed it by putting it in the parentheses here. Most introductory students would not distinguish this term like this. They would just leave it as negative C. If you leave it as negative C, you have what I call a dangling negative sign. The negative sign is just sort of in the front all by itself, and it's easy to forget about that. So if we subtract B to the other side, that's a totally correct approach, but we can see that C should have a negative sign in front of it still. We didn't get rid of that negative sign, so it should still be there. How do you avoid that kind of mistake? I would recommend when you're solving a formula, you don't always necessarily go right for the answer. Sometimes what you do is you set yourself up for an appropriate answer. So if I was solving for this one, I might look at this negative sign and be like, that might be a problem. You know what I might do to begin with is I might actually just add C to both sides. Now, if I add C to both sides, your first response will be like, well, transparent physics, that really didn't help out as well because we still have A plus C and we have B. So we haven't gotten C by itself. Yeah, it's true we haven't gotten C by itself, but we've created a situation where we are more primed for success because A plus C, the answer to that in order to get C by itself is we want to subtract A from both sides. So we subtract A from both sides, and then we have C equals B minus A. And that is the correct answer. So sometimes, sort of I guess a twofer for this one, watch out if you are manipulating and you are left with a term that has a negative sign. If I had done this the way maybe an average introductory physics students might, I might have said A equals B minus C minus B minus B, and then we have A minus B equals C. That is a very common mistake that I see. You take care of this negative sign here, and then you kind of forget that there is a leading negative sign, and it just disappears. So don't be afraid to take a longer approach if it's going to get you to the right answer. Here, by solving, by moving C first to the other side, I'm not necessarily getting closer to an answer, but I'm setting myself up to get the answer more easily. So that's a 2-for-1, a BOGO, if you will. And so appropriate time for a sip of tea. Okay, let's take a look at scenario number 2. So scenario number 2, we are interested in solving for C, and that's not going to change. I like that this time. Okay, so we're taking a look at this problem. If it's B divided by C, we want to get C by itself. So if B is on the top of a fraction, what we could do is we could divide both sides by B. If something's on the top of the fraction, we divide both sides by B to get rid of it. So it's A over B. B cancels out and leaves us with C. Okay, and that is our answer. So the mistake in this solution is not that, I mean, if you have B on the top of the fraction and B on the bottom of the fraction, it will cancel out. But it doesn't leave us with C. C was in the bottom of the fraction. So we have promoted C from the denominator into the numerator without any mathematics backing it up. Another sort of common mistake in terms of watching out for really this should be 1 over C. Let's show you how you can avoid that approach. So instead, this is basically another example in the philosophy where you might want to take a slightly longer approach in order to avoid possible mistakes. So we are interested in solving for C, but instead of trying to get C by itself right away, why don't we get C somewhere better? Let's multiply both sides by C. So we have C times A equals B. And then that's a pretty straightforward approach, right? We want to get C by itself, so we divide both sides by A. So C equals B divided by A. Now this approach on the left is not a totally lost cause if you had done it properly. Getting rid of the B on the top of the fraction technically should have left us this. And this is not bad. I mean, it's 1 over C. What you could do, this is a little bit more advanced, but you could basically flip both sides of the fraction, take the inverse of each side. So it's B over A equals C over 1. And you can see those are the same solution now, B over A equals C. So this is actually this is good now. But it wasn't before when we simply had the C by itself. So watch out for that one. Illegal promotion from the denominator. 2 days in school suspension. Round 3. Solve for D. I'll give you a second to look at this. How would you do it? Actually, I guess I don't need to give you a second. You can just pause it if you want to. All right, solve for D. So it is, let me get the red pen out here. It is A equals B plus C times D. So to get D by itself, I divide by C, right? So I divide by C, divide by C. So we have A over C equals B plus D. And then we get D by itself. So we subtract B from both sides, minus B, minus B. So it would be A over C minus B equals D. Where is my mistake? My mistake comes in the first step that I did. where I got rid of the c. Getting rid of the c here is the right instinct if you want to get d by itself. However, you've got another term here. You've got an addition term. When you're mixing addition and multiplication, or addition and division, or basically addition slash subtraction versus multiplication slash division, you have to be careful when you're mixing those together. If I'm dividing by c, I have to divide everything by c. So I can't divide one term by c and not divide the other term. That's where my mistake was. This has to be b divided by c. And if you actually follow that rule, you can see that you really don't get much closer at all using this approach, because you get the c out of this term, but you would end up with an over c in this term. So you're not actually moving c entirely to the other side of the equation. Whatever you do to one term, you have to do to the other term. And what I refer to as terms is items that are separated by like plus or minus. They're not just strung together with multiplication and addition. How can you avoid that problem? Well, let's start fresh. A equals b plus cd. This goes back to advice I gave in the previous video, which is work from the outside in. Instead of going right for the c times d, get rid of the b first. How do you get rid of the b? Subtract b. So it's a minus b equals c times d. And now how do you get d by itself? Now you can divide by c, because there's no other terms to mess you up. So we have d equals a minus b over c. Okay, and that's a good approach. That works. Be careful what order you decide to do things in. Dividing by c could be a good step, but maybe not in the order that you want to. So working from the outside in is a good default approach to try to build into the system a chance to avoid some of those common mistakes. All right, round 4. Solve for a. Okay, in solving for a, what we are interested in doing, we want to get, this one doesn't look too bad, right? So we're going to subtract b from both sides. So, get my red pen up. Minus b. So we have a equals c minus b over d. And there we are. What possibly could be wrong with that? We subtracted b from both sides. Nicely done. The problem with that is that c over d was already its own term. When we are subtracting b to the other side, you can't automatically add it to the numerator here, because then not only are you subtracting a b, but you're also now adding in a division by d. That's another mathematical operation that you're adding to this that wasn't justified by simply moving it over. All you're doing is subtracting it. So you have to be careful about moving things into or out of fractions. There are rules that govern that. So if I have a plus b equals c over d, the correct approach is subtracting b. Totally agree with that. But it should be a equals c over d minus b. This fraction was already set before you got here, so you can't just tack a negative b into it. That actually changes the value. Okay. Just watch out for that. Okay, here's number 5. Number 5 asks us to solve for a, and this one's going to be a little bit different. Solving for a, we want to get rid of b in the denominator, so we multiply both sides by b. This time, I'm going to give you 3 different possible answers for how this might look, and you tell me which one is correct. So it's going to be a on this side. So we might have a equals B times C over D. We might have B times C over D. We might have B over D times C. What do we end up with? Which of these is incorrect? And the answer is none of them. These are all correct. Number 5 deals with the idea that you can have things that look different, but they're still the same. Sometimes a student will look, and the person next to them, when they're working on practice problems, it doesn't look the exact same way that theirs does, so they think that they made a mistake. But all 3 of these values, even though cosmetically it looks like there's different, like here that kind of looks like it's outside the fraction, here it looks like it's outside the fraction, here they're all together in the fraction, it doesn't matter. These are all the exact same terminology. So number 5 is just suggesting to watch out for cosmetic differences. Things that look like they could be a mistake could actually be correct. Okay. And again, we could do this for an hour. We'll just wrap up on this one real quick. Number 6, taking a look at this problem. This we are interested in solving for h. So we have h squared plus bh plus c equals 0. And there are actually, there's an equation or two in introductory physics that actually has this format that you might have to solve. My piece of advice to you is watch out when you have a term that is an h squared and an h in the same equation. This is what we call a quadratic equation. If you attempt to algebraically solve for h here, I'm not saying you're not going to do it correct, because I don't know you, I don't know your skills, but it is extremely challenging to get this correct, because most students cannot do this without making a mistake. In fact, most people can't do this without making a mistake, which is why there is a shortcut available to us. And again, since this is the quadratic equation, you might be a little more familiar seeing it like this: ax squared plus bx plus c equals 0. That might look a little more familiar too. And in that format, if you remember, x equals minus b plus or minus b squared minus 4, no, I just got b 4ac over 2a. Watch your quadratic equations. When they sneak in and you want to solve for the term that is both squared and just a single term, attempting to solve for that term algebraically is probably going to get you in a bad place. Now, this equation, if you wanted to solve for a or b or c, you just go about using your normal techniques. But watch out for the quadratics. It is a very, very, very easy and common place to make a mistake, because you try to solve for it and it's just super hard to do. All right, this is not an exhaustive list of possible mistakes. And remember, mistakes aren't a problem unless you don't learn from them before the exam. So get your mistakes out of the way. And until next time, I hope we've made this topic a little clearer for you with this lesson of transparent physics.